Hello students, today we are going to study there are the SR latches, RS latch or SR latch using NAND or NOR gate. Today we study SR latch using NAND gate. SR latch using NAND gate. NAND gates. This is a SR latch. In this SR latch there are the NAND gates. That NAND gates are input, and for another NAND gate there is the S input, and this is the cross coupling, and output is Q and Q bar. This is a SR latch using NAND. You have to study that SR latch using here only change the NOR gates. And in this SR latch, first is when S is equal to 0, R is equal to 0. S is equal to 0, R is equal to 0. Then when any one of the input NAND gate becomes 0, S0, R0, when anyone that truth table of NAND gate, any one input of the NAND gate becomes 0, output forced to be 1. Output forced to be 1, that is S is equal to 0, R is equal to 0, Q and QR both are equal to be 1. This is the undetermined state, and there is this state is avoided because this state is called as a rest condition, because Q and Q and Q bar are, these are the output, Q and Q bar are not complement of each other. So that condition is called as a rest condition. When S is equal to 0, R is equal to 1. S is equal to 0, S is equal to 0, Q bar is equal to 1. Q bar is equal to 1, Q bar is equal to 1. So R1 S1, R1 S1, this state. So NAND gate of 1 is input of NAND gate of 1, Q is equal to forced to be 1. Q is equal to 0. In that condition Q is equal to 0 and Q bar is equal to 1. So this condition is called as a reset condition. That condition is called as a reset condition. When S is equal to 1, R is equal to 0. S is equal to 1, Q bar is equal to 0. Q bar is equal to 0. This is for NAND gate 1. There are input are 1 0 and this NAND gate, hence both the inputs gate are NAND gate 2 are 1. So Q bar is equal to 0. Q bar is equal to 0. So Q is equal to 1. So this condition is called as a set condition. This is called as a set condition. And when S is equal to 1, R is equal to 1. S is equal to 1, R is equal to 1. There is the S is equal to 1, R is equal to 1. Q and Q bar is equal to 0. Q bar is equal to 0. That is the equation of Qn and Qn plus 1 by using the De Morgan's theorem. That is the for this condition there is the no change in the output of S is equal to 1 and R is equal to 1. There is the no change in the equation or in a no change in the output. So that condition is called as a no change. Means S and R is equal to 0, both the forced to be, the output will be forced to be 1. So this condition is a rest condition, that Q and Q bar are not complement of each other. So this condition should be avoided. When S is equal to 0, R is equal to 1, the outputs of Q is equal to 0 and Q bar is equal to 1. That condition is called as a reset. When S is equal to 1, R is equal to 0, then outputs Q is equal to 1, Q bar is equal to 0. That condition is called as set condition. And when S is equal to 1, R is equal to 1, that there is a no change in the output state, that is a no change in the state, that state is a no change. So from this diagram there is a block diagram of SR latch. S input, R inputs, and outputs are Q and Q bar. And from this explanation there is a truth table of SR latch, that is S input, R input, Qn plus 1, that is a present state and next state, that is a Qn bar. S is equal to 0, R is equal to 0, that condition is a rest condition, that is a no change in this condition. When S is equal to 0, R is equal to 0, so R is equal to 1, that is a Q is equal to 0, R is equal to 1, Q is 0, that condition is a reset state. When S is equal to 1, R is equal to 0, output 1 and 0, that condition is a set. When S is equal to 1, R is equal to 1, there is a Qn as a Qn and Qn bar as a Qn bar, so that condition is a no change, that is an inactive state. This is the SR latch using NAND. Next you have to implement SR latch using NOR gate also and prepare the truth table. That is the homework for you. This is the SR latch using NAND. Next is the triggering methods. That is the triggering methods. In this triggering method there are the two triggering methods. In this triggering methods, latch and flip-flops, that additional signal is called as a clock signal, and depending upon the portion of clock signal, the latch or flip-flop will be respond, and then this classified into two types, that is level triggered circuit and edge triggered circuit. Difference between latch and flip-flop, that latch and flip-flop both are basically bistable element, and latch has got an enable input, and as long as it is active, the latch output will be kept changing according to the change of its input. On an other words, that is a latch is a level triggered flip-flop, but flip-flop is a sequential circuit which generally samples the inputs and changes the outputs only particular instant of time, not a continuously. This is the difference between flip-flop and latch. The flip-flops are to be said to be edge triggered or edge sensitive triggered, and being the level triggered like as the latches. That is the latches, and that is there are the two level triggering methods, level triggered and edge triggered. That is the first is a level triggered. This is the clock signal is applied for the flip-flop. This is a flip-flop, S input, R input, output as a Q and Q bar. And for these inputs there are the one enable input is applied, and this is the R input, this is the enable input, and for that enable as a clock signal. When this clock signal is applied, then output will be changed. Means what? This is the clock signal. In this clock signal, flip-flop will be respond to change their state. This state is level, this state is high logic, this is the low. This SR flip-flop, only flip-flop does not respond when the level enable is low. Enable, this is the low level. That flip-flop does not respond with level of enable signal is a low. Enable signal is a low. Enable signal is a low, and here enable signal is high. SR flip-flop is enable and will be when level is high. When level is high. This is the clock signal, and from this clock signal, latch or flip-flop circuits which responds to change their inputs if and only if this SR latch or flip-flops will be response to change if and only if enable signal is held high, enable signal is held active high or low level, that is called as a level triggered of flip-flop. So circuit will be respond to change only rising and falling edges of the levels. This is only steady state, steady high or low levels of the clock signal. Means when this clock signal is a high level, then flip-flop is, that enable signal is 1, then flip-flop will change their output. When in this low level, this is a low level, means enable is 0, flip-flop will not be change their state. Means for the level triggering method, that is the first triggering method is a level triggered. In this level triggered, this is a low level, and this is the high level. This is high level means flip-flop will changes their output when enable signal is a high, when enable level is a high, and when enable is 0, flip-flop will does not respond to change their, this is the low level, this is the low level, this is the low level. And this latch or flip-flop of circuit which responds to change only if and only enable input is active level which may be either high or low level, that is called as a level triggered, that is called as a level triggered. And in this level triggered there are the two types, positive level triggered and negative level triggered. If the output of flip-flop response to input change only if clock input is high. Clock input is high, this is a clock input is high, that trigger is called as, that level is called as a positive level. The output of flip-flop respond to input change only when clock input is low. Clock input is low, this is the level is a clock of low level, and that flip-flop output will be changed. That triggering method is called as a negative level triggered. Negative triggered method. Triggering methods are two, that is the low level triggered method and edge trigger. And in again level trigger there are the two types, positive level triggered and negative level trigger. Next is a edge trigger. In this edge triggering there are the, in this edge triggering there is the flip-flop which changes their, this is the clock signal is applied for flip-flop. In this flip-flop which change their outputs only corresponding to positive rising or falling edge of the clock. Falling or rising edge of the clock input are called as a edge trigger, and these flip-flops are there to, are said to be edge triggered or not a sensitive, or these are rather and not a level triggered. In this rectangle signal, clock signal is applied, clock input of the flip-flop. If the same signal is applied as a clock signal to edge trigger of flip-flop, then outputs will change only at the rising or falling edge of the clock signal. So the edge triggered flip-flop does not respond to change, only levels, not levels. In a every clock there is a falling and rising edge, in that edges flip-flop will be changed. But in a level trigger, when clock signal is low level or high level, then flip-flop will be response to change their output. But in a edge trigger, for every clock signal there is a, this is the rising edge and this is the falling edge, this is the rising edge and falling edge. Flip-flop will be particular within that time will be change their output. That is called as a edge trigger. This is the edge trigger. This is the form low to high level, low to high, that is a this is a positive edge trigger, and this is the form low to high level, high to low level, that is a low negative edge trigger, that is the negative. Means flip-flop which they change their output corresponding of the clock of the rising and falling edges changes their outputs, that is called as a edge trigger. But in a level trigger of clock, when clock is applied, for that clock there are the two levels, low level and high level, that level output will be changed their flip-flop. But in a edge trigger, for every clock signal there is the one edges, falling edge and rising edge, in that their output will be changed, that is called as a edge trigger. And that edge trigger is again divided into two types, that is a positive edge trigger and negative edge trigger. Positive edge trigger flip-flop will be allow its output is changed to response to its inputs only at the instant of corresponding rising edge of the clock, that is called as a rising edge of the clock, that is called as a positive edge trigger. Its output does not change, does not respond to change in input at any other instant of time. And negative edge trigger of flip-flop will respond only negative edge of the clock. This is the negative edge of the clock. At that time change their output in this output. But in level trigger there are the clock high and low level, that time flip-flop will be changed output. In a edge trigger that is the output will be edge trigger. Flip-flop samples inputs at the positive and negative and changes that outputs are accordingly. But in a level trigger there is the flip-flop output changes when clock input is either high or low level. And in this there the edge trigger, in this edge trigger flip-flop samples the outputs at the positive edges and negative edges, and it changes its outputs accordingly. That is called as a edge triggered method. Next lecture we study the types of flip-flops.